In this next section, we're going to talk about data collection and experimental design. So starting out with the idea of designing a statistical study. First off, they talk about how you want to identify the variables of interest, which is the focus and the population of the study. So what's going to be measured and what are we going to measure it on? So the variables and the population that's going to be surveyed or sampled from or studied. Then talk about developing a detailed plan for collecting the data. So if we're using a sample, a real important thing is we want to make sure that that sample is representative of the population. We want to pick out a group that as closely as we can reflects the population as a whole. Once a sample is identified, then the data is actually collected from that sample, either using a survey or observations or something that collects data from the sample. Once the data is collected, it's going to be just a giant, list of numbers or responses or something like that. So that's going to have to be organized, and then the data has to be described using descriptive statistics. And then finally, going into the inferential part of things, the data has to be interpreted and then make decisions about the population using those inferential statistics. And another thing that we can also talk about later in the course in more detail is how to identify any possible errors that could be there in the final numbers, and then those numbers which are leading us to our interpretations of the data itself. So starting out with the first important step, once we identify the variables in the population, is to consider a representative sample. So like I mentioned, it's a sample in which the relative characteristics of the sample are close to those in the population. And this is one of the first key steps that are taken in any statistical study. It's coming up with the sample and how it's going to be collected and how it's going to be chosen specifically. So let's talk a little bit about that. It says the first example, suppose you want to determine the average or mean height of all the students at a school. Which is more likely to be representative of a representative sample for the study, the men's basketball team or the students in the statistics class? Well, this is a fairly exaggerated example, really. It's clear one group is going to be taller on average than the other. So if you're looking to pick a sample which is representative of the school as a whole, probably not best to pick the basketball team specifically, because they're going to not be very representative. They'll be taller than average. So again, an exaggerated example of how a sample could be chosen, and you could take the average height, but it's not going to be representative of the overall population of the school. So going a step further here, let's talk about the two broad categories which are used for statistical studies. Starting out with what's called an observational study. In an observational study, researchers observe or measure characteristics of the subjects, but do not attempt to influence or modify these characteristics. These are usually going to be studies where a survey asks a question, such as if employees feel stressed. That would be observational, since it does not seek to change any outcomes. It's asking a question but not trying to change anything. It's strictly observational. This is in contrast to an experiment or an experimental study where researchers apply some kind of treatment and observe its effects on the subjects of the experiment. So they're actually trying to administer and attempting to influence change, then observe the results after something has changed. Medical studies usually fall within this category when they have new treatments that they're trying to test. So within that idea, let's talk about just sort of a general example here. It says, suppose you want to study if vitamin C has an effect on colds. Suppose people taking vitamin C daily get an average of 1.5 colds within a 3-month period. question, though, is how do we know if this is an improvement? We know some people are taking vitamin C, We know on average how many colds they get, but do we know if vitamin C is doing it or not? In order to even start to answer this question, some of the people have to take vitamin C and some of them have to not take vitamin C during the study. So you have to have at least these two groups within this experiment, the treatment group and the control group. And these two groups are usually randomly assigned to take any potential bias out of the process. So here's the definition for those two things. The treatment group in an experiment is a group of subjects who receive the treatment being tested, versus the control group in an experiment, which is the group of subjects who do not receive the treatment being tested. So let's talk about an example of this. The first one says, researchers study the effect of vitamin D3 supplements among patients with antibody deficiency or frequent respiratory tract infections. To perform the study, 70 patients received 4,000 IU of vitamin D3 daily for a year. Another group of 70 patients received a placebo daily for 1 year. We'll talk more about what the placebo means. Placebo basically means they don't receive the treatment itself. So one group receives the treatment and one group receives something which is not the treatment. That's what's called a placebo here. So what type of study is being ran here? Is it observational or is it experimental? Well, since they apply a treatment, there's a difference between the two groups. One has vitamin D3. We're going to call that an experimental study. The treatment group would receive the vitamin D3, while the control group would not receive the treatment. Let's look at another example. And this also has about researchers, but it says they're conducting a study to determine how confident Americans are in the U.S. economy. To perform the study, researchers called 3,040 U.S. adults and asked them to rate the current U.S. economic conditions and whether the U.S. economy is getting better or worse. And this is sort of a usual study that's conducted and then the results are presented in the news and so forth. But I put down here that this particular study does not attempt to influence the responses of the subjects. There is no treatment. There's no experiment being ran here. It's simply an observational study. So those are the two types of studies we might encounter: an experiment or experimental study where there's a treatment being given to try to influence a change, or an observational study where they're just passively collecting data, not trying to change anything in the long run. Another definition to mention here is the definition of variable. And for us, we're going to consider a variable as any quantity or any item that can vary or take on different values. So something that can take on different values will be considered a variable. When cause and effect might be involved in a situation, we call the explanatory variable the variable that may explain or cause the effect, while a response variable is a variable that responds to changes in the explanatory variable. So usually what they try to do is change the explanatory variable and see what response happens as a result. If there's a change in the response variable, then we can try to make the case that the explanatory variable is what caused it to change. So just some definitions in case we need to refer back to this idea of explanatory versus response. Now, talking again about these experiments, it's very tricky at times to figure out how to construct things in the best way. But we know for sure that using control groups are necessary to help account for the unknown variables, things that could be there that we're not controlling for. However, what if there are other variables influencing things that are not taken into account? So for instance, earlier I mentioned the case of some people taking vitamin D3 versus not taking vitamin D3. The vitamin D3, either taking it or not taking it, is the variable here. And we're controlling that variable by either having it or not having it in order to see what happens in either case. But in most situations, there are a lot of variables that could influence the outcomes. And when this happens and it's not taken into account, a study will suffer from what's called confounding. A study suffers from confounding if the effects of different variables are mixed so that we cannot determine the specific effects of the variables of interest. The variables that lead to the confusion are called the confounding variables. So, a confounding variable occurs when an experimenter cannot tell the difference between the effects of different factors on the variable itself. We'll look at some examples of where confounding shows up and how to perhaps deal with it in some cases. One commonly referred to type of confounding is one when an experiment involves people. The effects can simply occur because people know they are part of the experiment. So this is sort of a psychological factor. And when this happens, it's called the placebo effect and has detrimental effects on the statistical results. And these effects can be lessened by the use of what we refer to as the placebo. So I mentioned that in that earlier example. The placebo was given to the group that did not receive the treatment. And that's because a placebo lacks the active ingredients of a treatment being tested in the study, but looks or feels like the treatment, so that the participants do not know whether they are receiving the placebo or the real treatment. And so that placebo effect refers to the situation in which patients improve simply because they believe they are receiving a useful treatment. So this is a very real thing that happens that has to be taken into account for. And to go a step further, they need to also take into consideration who knows who gets their treatment and who knows who's not receiving a treatment, which gives rise to what's called blinding. So in order to overcome the placebo effect, we use what's called blinding, either single blind or double blind. In a single blind study, participants do not know whether they are members of the treatment group or members of the control group. But the people who are experimenting, the experimenters, the people who keep track of things, they do know who's part of which group. However, that can give some problems if the key people collecting the data know they could also have some psychological factors which influence the outcomes and thus confound the results. So in a lot of cases, they try to run what's called a double-blind study. In this case, neither participants nor any of the experimenters know who belongs to the treatment group and who belongs to the control group. So it's completely set up so that nobody knows who is taking the treatment, who is taking the placebo until after the study has completed, and then they can check to see who was who and put together the results. And this takes out any possibility, or I should say helps to take out any possible biases or placebo effects that could influence the outcome, other again than the treatment itself, which they're trying to see if it makes a difference. Now, talking about observational studies for a second, those are experimental studies when we need blinding. For observational studies, there's a couple different kinds that are often referred to. The most familiar observational studies are those in which data are collected all at once, or as close to that as possible. But there are two variations on this, called the retrospective or case control study, and the prospective or longitudinal study. A retrospective study uses data from the past, such as official records or past interviews. They don't actually go out and get any new data. They're just collecting past data and doing some statistics on that. Whereas a prospective study is set up to collect data in the future from groups that share common factors. So they set it up and then they want to continue to collect data for many years into the future to see what happens over a long period of time. That would be a prospective study. Let's talk about which one should we choose in certain cases. Looking at this example here, it says you want to know whether teens who try marijuana are more or less likely to abuse hard drugs as adults. What type of study would be appropriate here? Well, we've got a few different options. Of course, there are the experimental studies, but an experimental study involves using the control group and the treatment group. And the treatment group would have to be actually given the thing that's being studied, which in this case would be the marijuana. So would that really be an ethical thing to do? Not so much. So what would usually be done in this case is an observational study. When there are any ethical concerns about an experiment, those usually take precedence if at all possible. So if an experiment can't be done, then let's see about an observational study. Here, a retrospective as well. That would be set up in a way of looking at past experiences. Again, retrospective, looking into the past. So they might look at, experiences from people who did try it and then what happened to them, things like that. But they're not actually experimenting directly. They're just looking at what's already occurred and then trying to create the statistical study from there. To go back to the topic of confounding, if the treatment and control groups can differ in very important ways, that's a really important place where confounding can result. So researchers try to overcome this in two different ways: selecting groups at random and using sufficiently large groups. So this is an important step here because choosing things at random or choosing large groups helps take out some potential biases. And those biases are confounding factors as well. So when talking about selecting groups at random, they say here to make sure that the subjects of the experiment are assigned to the treatment or control group at random, meaning that each subject has an equal chance of being assigned to either group. So nobody's weighting the selection to one group or the other. It's just completely random. Large groups also help because if we make sure that the treatment and control groups are sufficiently large, that they're unlikely to differ in any significant way, aside from the fact that one group gets the treatment and the other group does not. Let's go through a scenario and talk it through with some of these ideas. This one says, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with each experimental design and suggest a way to improve it. So they're trying to test a treatment, a new gum developed to help people quit smoking. And one way of potentially doing this is they identify 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the new gum have quit smoking. Let's evaluate that. Did they use a treatment and control group? Looks like they did. And they use a placebo. So they gave 5 subjects something that looked like the gum, so they thought they were getting it when they weren't. So you had your treatment group, you had your control group, you had the placebo. The big issue here is the sample size. They only had 10 adults, 5 who took the gum and 5 who did not. It's not really a large enough to validate the results of the experiment. They have to be able to replicate it over a larger group of people in order to prove the validity of the result that they have. Because in small groups, random chance could play a role in how the outcomes actually occurred here. Here's a second way it could possibly be done. They identify 1,000 adults who are heavy smokers, so a much bigger group here, so the sample size is a lot larger. Their subjects, though, are divided into blocks according to gender. Females are given new gum and males are given the placebo. After 2 months, a significant number of the female subjects have quit smoking. Well, the issue here is not a random assignment so much, but they assigned it according to gender. And so that's a kind of choosing the groups with a particular situation, separating the two. The groups are not similar groups, they're different. So the new gum may have a greater effect on men or women or vice versa. The subjects can be divided into blocks according to gender, but then if they were going to do that, if that was a part of something they were trying to test, they should randomly assigned to the treatment or the control group. Here they did not. The treatment group was one gender and the control group was the other. So going another step further here to look at some other examples, which each one of these questions, if they were to try to develop a statistical study, what would be an appropriate type of study to use? Observational, experimental, do they need blinding or no blinding? And things like that. Let's look at the first one. Average income of stockbrokers. If they wanted to keep track of this, record it, and do a study on the average income of stockbrokers, really not a situation where an experimental study would make sense. So they would do an observational survey. On the other hand, do seatbelts save lives? This could be set up as an experiment with a treatment group who use seatbelts and a control group who do not, but that's not really an ethical thing to do, to put lives at risk if that potentially influences things. So the only way to do it is to probably use an observational study, but they could use retrospective observational study because they could look back on data that's already been collected about people who use seatbelts and people who did not. On the next one, it says, can lifting weights improve runners' times in a 10-kilometer or a 10K race? Well, this one makes sense to do an experiment. You can have one group that lifts weights and one group that does not lift weights. So you can have your treatment and control group here with no ethical issues. And you can measure to see those who lift weights if they actually improved their performance. And I would say in this case like this that no blinding is really needed. There's no real way to keep it secret who is in the treatment and who is in the control group. The treatment group's going to be lifting weights, so they know they're part of that group, and the control group's not. So it doesn't really matter in that case. Ultimately, the performance will be measured in an objective sense when they're in the race. So the placebo effect is not such a big issue there. Now the next one, however, it says, does skin contact with a particular glue cause a rash? Well, we do understand that that would be an experimental study where one group is exposed and one group is not exposed to the particular glue. It's not a huge ethical concern either, because they're not trying to do anything too dangerous there. Single blinding might make sense here, just to make sure there's no influence on the placebo effect. So an experimental single-blinded study could be used there. The next one says, new herbal remedy to reduce the severity of colds. Well, that would be experimental. The treatment group gets the herbal remedy. The control group does not, but they will need a placebo to make sure that those people who do not get the remedy get something that looks like it, but doesn't actually have any effect. So that people aren't feeling better just because they think they're getting something. So that takes the confounding out of it. You know, some people might feel better just by getting the placebo, but it would be more of a random thing rather than a effect of their just getting it. So double blind, I also say here as well, because the experimenters could influence how people feel when they're interviewing them or doing checkups or something like that, if they know who has the remedy and who does not. So double blind takes that out of the process as well. And then the last one says supplements of this particular extract from red grapes, does it increase lifespan? This would be more of an experiment because people would have to take it, but I put it as a prospective experiment. Perspective being it has to look toward the future, so they're not going to be able to measure increased lifespan without waiting a long time, and so they'd have to call that a prospective experiment. Now, in the discussion of bias, it's important to discuss what could possibly influence the results one way or the other. We only want, in an experimental study, the results to be influenced by the thing that we're trying to study. and nothing else. But in the real world, there's so many influences, so many variables that they try their best. Statisticians try their best to reduce bias when they're trying to make a sound statistical study. Selecting the sample is really important, like we were talking about earlier. It's possible to select a sample that isn't representative, and in that case, the results that are received don't really tell us about the population. So selecting the sample appropriately, here are some different definitions for that. First off, a random sample is one in which every member of the population has an equal chance of being selected to be part of the sample. And this leads us to what's called simple random sampling, where every possible sample of a particular size has an equal chance of being selected. This is one of the first ways to try to reduce bias. So if it's just random, nobody's going to have a chance to influence the results one way or the other. So that's taken out of the process entirely. And so here's one way where it could fail, though, to work if we're not careful. It says you want to conduct an opinion poll in which the population is all the residents in a particular town. Could you choose a simple random sample by selecting names from the local property tax records? Let's think about it. So what's the population here? It's all the residents in a particular town. Now they're choosing them at random, so they're not picking them out on purpose to bias it in any way. But notice how they're only choosing from a selection, but it doesn't include the entire population of the town. So just using the property tax records, this is going to miss many residents in the town. Only those that own property would be possible to be selected, whereas people who don't own property, there would be no chance of them being selected. So this could possibly influence the outcome if the population being studied is supposed to be all residents in the town. It's not probably going to come out with a very representative sample. So overall, there are a few different sampling methods. We're going to talk about a few briefly here. The first few here are called what we looked at, the simple random sampling, where we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. And for the most part, this is going to be what we're going to be using through the semester. But there are others that you might see out there in statistical studies. One of them that's called the systematic sampling, where we use a simple system to choose the sample, such as selecting every 10th or every 50th member of the population. There's also convenient sampling, where we choose a sample that happens just to be a convenient one to select. There's also two that are very similar but distinct, called cluster and stratified. In cluster sampling, we first divide the population into groups or clusters, and then we select some of the clusters at random. We then obtain a sample by choosing all of the members within each of the selected clusters. This is different than stratified sampling. In stratified sampling, we first identify the strata or subgroups and draw a random sample within each subgroups. The total sample consists of random samples from within all of the individual subgroups. So they're very similar, but the key difference here is that in the stratified sampling, within cluster sampling, we only select some of the clusters at random. So not every cluster gets chosen, or not every group gets chosen in cluster sampling. We choose some of the groups, but then we use all of the members within each of the groups that are selected. On the other hand, stratified will use all of the groups, but only pick some of the ones within each of the groups. So every group gets a little bit used in stratified sampling, but only to a certain extent because we randomly choose within each. Versus the cluster sampling, where we choose everything within the selected groups. Here's an illustration of these different ones. Again, simple random sampling, it's just got a big list of numbers and it's picked out at random. Convenience sampling would be just like asking a question out your window. It's a convenient thing to do. We call it convenience sampling. Systematic sampling, again, it's like just a system of choosing every 10th or every 5th or every 3rd member of the population. And then cluster versus stratified. And so cluster, it's like you've got these groups here, and then each group is picked at random, and then everything within each of those groups is used in the sample. Versus stratified, where you've got 2 groups, and you're going to pick a little bit from out of each group at random. So here being 2 groups, and then they pick out like 4 out of each of those groups. So let's go through a few examples of this. It says, when the National Air and Space Museum wanted to test possible ideas for a new solar exhibit, a staff member interviewed a sample of visitors, selecting a visitor exactly every 15 minutes as they entered the exhibit. So what kind of sampling method would we call this? Selecting a visitor every 15 minutes. Because there's a system to it, we would refer to it as systematic. It follows a rule, in this case 15 minutes. Is it reasonable to think that this would make a representative sample? Would we get an assortment of people surveyed representative of those who visit the exhibit? Well, probably. You're going to get a little bit of each kind of at random through our visiting. You're not going to influence or bias it toward one group or the other, especially if it goes throughout the whole day that it's open. You get some people who come in the morning, afternoon, evening, things like that. So it should be, at least on the surface, seems to be a fairly representative way of doing it here. Here's another example. It says a supermarket wants to decide whether to carry a new brand of salsa. So they offer free tastes at a stand in the store and ask people what they think. What type of sampling would be used in this case? Well, we would refer to this as convenience sampling because, again, they're choosing people in a way that's just convenient. They're not using a system or something like that, just people who come up and decide to take a sample. Would it be representative of the population, though, of all shoppers? Think about what group would tend to go take part in this survey. Would they be representative of all shoppers? Not so much, because people who like salsa or are interested in different types, they would be more willing and generally would be the ones to go get a sample. So you're getting a sample that's representative of a certain group of people, but not necessarily all shoppers in general, people who like it and people who don't like it. So we really wouldn't say it's representative of all shoppers. Now, perhaps if we change the population to people who want to buy salsa, then it might be better. But if we're talking all shoppers, not so much that idea for representative sample here. Here's another commonly referred to in the news. It says the U.S. Labor Department surveys 60,000 households each month to compile its unemployment report. To select these households, the department first groups cities and counties into about 2,000 geographic areas. It then randomly selects households to survey within each of these geographic areas. Now it tells us what kind this is. Let's talk about, this is what they would call stratified sampling. Here's the reason why. They group all households. All households is their population in this case. And they're trying to survey from all the households in the U.S. So they create subgroups, which again are also referred to as strata, and these are 2,000 geographic areas. And then we randomly select from within each of the geographic areas. That's why they call it stratified, because their random sample is taken from with each of all of those subgroups that are determined here. It's important that they do this because stratified sampling is used when they want to cover, say, like a large land area without having to make a huge sample. So they're getting a little bit from each geographic area so that they fairly represent the entirety of the U.S. households in this case. Okay, here's a whole assortment of different scenarios, and we're going to go through classifying if they use what type of sampling that we've seen up to now. So let's start with the first one here. It says an apple harvest from an orchard is collected in 1,200 baskets. An agricultural inspector randomly selects 25 baskets and then checks every apple in each of these baskets for worms. Let's think about the population here. The population would be all the apples they collected in this harvest. Now, obviously, they're not going to study every single apple. They're just going to take a sample and make sure that it's representative. Now, they don't choose all the baskets either. They pick 25 baskets, and then they check every apple in one of those baskets. This would be what we call cluster sampling, because they begin by selecting the baskets at random. Those are the clusters. They don't go to every cluster. They only pick out some of them, and then they check every single item within the cluster. So every single apple within each basket that was randomly chosen. That would be an example of cluster sampling. The next one says an educational researcher wants to know whether at a particular college men or women tend to ask more questions in class. Of the 10,000 students at the college, she interviews 50 randomly selected men and 50 randomly selected women. What type of sampling would this be? Well, in this case, there are grouping to it, men versus women. And those would represent the different so-called strata. And so they would call this stratified sampling. Notice again that within each of the groups, they randomly select men, women, and then they randomly select a little bit from each group. That's the key characteristic of stratified sampling. In the next one, it says, in trying to learn about planetary systems, astronomers conduct a survey by looking for planets among 100 nearby stars. Notice there's no grouping here, so it's not really going to be stratified or cluster sampling. It's done by looking at what is nearby, and therefore we think of it as a convenience sampling. Since the astronomers presumably focus just on nearby stars because they're easier to study, it's an example of convenience sampling. And then the next one says, to determine who will win an autographed football, a computer program randomly selects the ticket numbers of 11 people in a stadium filled with people. There's no real system here. It's just a matter of randomly picking them out from a giant list. So because it's selected at random and every ticket number has an equal chance of being selected, this would just be called simple random sampling. If you'd like to try a few of these on your own, here are a few scenarios. I have the solutions to these in my slides. In the first one, 2 scenarios to determine whether the study is an observational or an experimental study. You could read these through and see what you think, if you think it's experimental or observational, and then check to see what they are. And then a few examples will be here for identifying what type of sampling method is used. So the simple random, convenience, systematic, cluster, or stratified, which one would apply to these scenarios here?